Oh yeah, here we go. Time to discuss the mole. It's a measurement of matter we use a lot in chemistry. So for this lecture, be able to define mole. No, not the tiny fuzzy one. The one that means a simple mole of a substance is 6.02 times 10 to the 23rd representative particles of that substance. Avogadro's number. This is 6.02 times 10 to the 23rd. It's the number of representative particles in a mole. And last, you can guess representative particle, which means this whatever is present in a substance. Usually it's atoms if you're thinking about elements, or molecules if you're thinking about a molecular substance, or a formula unit if you're thinking of an ionic substance. Okay, real last, molar mass. And that's going to be the mass of, well, a mole of that substance. All right, calculate the number of atoms. Nope, you don't have to count them, don't worry. Or particles if given the mass of a sample of a pure substance. Predict what the mass of a mole of an element or compound will be, and calculate the molar mass of a compound. So think about counting. If we went to the grocery store, we'd probably buy a certain number of apples. Like when I go shopping, I pick one per person in the family per lunch time that we're going to want an apple. So you probably, if you were the grocery store though, you're probably not going to count the apples. You'll probably buy them by the bushel or by the crate or something like that. There are different units of measurement for when we're measuring a small number of things and when we're measuring a very large number of things. Think truckloads of apples, for example. So how could you determine how many apples are in that truck? So think that one over and realize that there's a quick way of doing this, just measuring the mass and then dividing by the number, the individual mass. So that's kind of what is done with moles. So let's really kind of work through this. A mole is an amount of substance with 6.02 times 10 to the 23rd units of that substance. For carbon, this is 6.02 times 10 to the 23rd atoms. For water, this is 6.02 times 10 to the 23rd molecules. And for barium sulfate, this is 6.02 times 10 to the 23rd atoms of barium and of sulfur, so of both. And this is what we mean by representative particles. It's the unit by which we're measuring a substance, the atom, the molecule, or the representative unit of an ionic compound. So how many atoms are in, for example, 0.15 moles of calcium? How many moles of water are there if we have 100 billion water molecules? How many atoms are in 2 moles of calcium fluoride? Now, another way of looking at this is the molar mass. The molar mass of an element is the atomic mass expressed in grams. So that means those little numbers you look at on the periodic table, if you take that many grams of that element, it is exactly 6.02 times 10 to the 23rd atoms of that element. So this is helpful for balancing reactions. Sodium chloride, how do you measure a certain amount of sodium that would go with the same amount of chlorine? Well, 22.99 grams of sodium, that's the molar mass of sodium. It's also what you see on the periodic table. And you take 35.45 grams of chlorine, that's 1 mole of chlorine. If you added them together, you're going to get an exact reaction because that's the same number of atoms of both. Real mind-blowing. Oh yeah. And that means that reactions have definite ratios, and they're very easy to determine. Well, until, of course, we make hard problems. But, you know, that's just our job as teachers. So how many moles of an element? Using the mass in grams divided by the molar mass, you can actually determine how many moles of an element you have. So let's say you have 50 grams of carbon. You take that 50 grams and divide it by 12.011. 2 kilograms of iron. So what do you see on the periodic table for the molar mass of iron? And 32.1 grams of sulfur. So how many moles of sulfur would that be? Well, that one's an easy one. So you're going to add the molar masses of elements together if you have a compound. So that copper 2 sulfate pentahydrate, well, you're going to take you actually have to know the chemical formula of that. Now, you know penta means 5, so 5 waters. And copper 2 sulfate, well, sulfate, that's not sulfide. So that's going to be SO3, and that has a 2 minus. So there's 1 copper, 1 sulfur, 3 oxygen, and then 5 H2O molecules in order to get that. So you see how that can get pretty complicated, and that's why there's so much of that in the little jar there. So using the subscripts helps you to know the number of elements. Remember that copper 2 sulfate, that SO3 means there are 3 oxygens present in each one of those compounds. And then you divide the mass of the sample, so weigh that out, by the molar mass of the compound. And of course, what you see here is 1 full mole of copper 2 sulfate pentahydrate.